Welcome to Chasing the Horizon, a podcast by, for, and about motorcyclists. This is episode 28, released on the 16th of August, 2018. Thanks for joining me. Welcome to Chasing the Horizon, brought to you by the BMW Motorcycle Owners of America. Subscribe through your favorite podcast player or app, or stream from the website at horizon.bmwmoa.org. Thanks for joining me and all our other regular listeners. After the all Harley news incident from episode 27, I wanted to make sure I gave some coverage to other brands, so in this episode you won't hear any Harley-Davidson news at all. Well, except for this one thing, and it's really more about a person than the brand. You might remember listening to episode 20, in which I talked to Eric Risto and Neil Olson about their film/series project called The Last Motorcycle on Earth. In that episode, I told you about Harley's summer internship program and may have even encouraged you to apply for it. One of the more than 7,500 applicants was a senior from the University of Wisconsin at Oshkosh named Tessa Otto. Since she took possession of her Street Glide and started working as an intern, she's racked up over 8,000 miles and recently surfaced in Sturgis, South Dakota at the big annual rally held there. She rode from Wisconsin with her father, who also rides a Street Glide. I think that's very sweet. In an article in USA Today, she said she hadn't driven her car since June and had even had to ride several 500-mile days in a row. So no matter what else she's got going on, you know she's putting in some good saddle time. Let's jump over to India now. If you're a regular listener, you know a number of European manufacturers have teamed up with companies in India to manufacture small displacement bikes. Triumph and KTM have teamed up with Bajaj, and BMW teamed up with TVS for their G310 series. We can now add Ducati to the mix. There are credible reports coming out that the iconic Italian builder is putting together a partnership with Hero Motocorp to build bikes in the 300cc range, most likely an entry-level sport bike like the ones put out by KTM and the Big Four in Japan. With Ducati's legacy in MotoGP, it isn't hard to imagine they can design a stellar bike for that segment, and certainly India's manufacturing concerns can handle the work. I just hope Ducati has studied up on what happened between Hero and Eric Buell in his attempt to resurrect his brand following the unceremonious shutdown of the original Buell line by Harley-Davidson. BMW had another tough quarter, announcing a 5.3% dip in motorcycle sales. In the second quarter of 2018, they pulled in $762 million, which sounds like a lot, but like I said, that's down just over 5% from the second quarter of 2017. BMW's chief financial officer, Nicholas Peter, blamed the drop on production delays, causing consumers to have to wait for new and updated models. Basically, with fewer bikes being built due to retooling in the factories to prepare for the new models, there were simply fewer bikes available in the dealerships for purchase. But things aren't all doom and gloom for BMW. High-speed record seeker Aaron Sills used an aerodynamically modified S1000RR to achieve a new land speed record of 229.266 miles per hour. That's just over 229 miles per hour on a motorcycle. The bike also sported some engine modifications, but remains naturally aspirated, which is a fancy way of saying the bike isn't turbo or supercharged and relies on good old-fashioned atmospheric pressure to get air into the combustion chambers. This is the 37th land speed record for Hunter Sills Racing and is notable in that Sills beat her late husband's record with this same engine by 8 seconds. Her fastest run during the event down in Bolivia was actually 242 miles per hour, but an electrical problem with the bike prevented her from making the return run that is critical to certifying any kind of record-setting run. For this episode's last bit of news, I'm going to tell you something about, you may have guessed it, Royal Enfield. Come on, you know it was coming sooner or later. This isn't big industry news, but it's more kind of lifestyle or promotional news for the brand. Royal Enfield has deployed an official adventure team in the Philippines, outfitting 3 riders with Himalayan motorcycles and charging them with being brand ambassadors all around the island nation and eventually even internationally. One of the riders joked that, quote, everything must be posted to Facebook, which I think might be a sign of the apocalypse, but time will tell. The reason I'm telling you this really is because I find it soothing somewhat to know that the adventure bike craze isn't limited to the United States and Europe, which is where I get most of my adventure bike news. There are people all over the world that love this style of bike, and it's comforting to me to know that the companies that build them are engaging with the genre's fans all over the world in a number of ways. By way of introduction for this particular episode, I'm going to tell a little story and then introduce my guest. A few months ago, I went to my audiologist, which as a recovering rock and roll musician and longtime motorcycle rider, I do with fairly frequent visits to get my hearing checked, sometimes to get new earplugs. And my audiologist told me a disturbing story about one of her neighbors who was electrocuted and killed by his motorcycle. And I thought that sounded a little strange. That is literally the first time I've ever heard of anybody being electrocuted to death by a motorcycle. So I thought I would seek out somebody that I know that knows a lot about motorcycle electronics, and that is this episode's guest, Stuart Ostroff. So Stuart, welcome to the show.
Thank you.
Now,
by the way,
yes,
being electrocuted means that you die.
Oh, okay.
So you don't get electrocuted to death.
You just get
electrocuted, and then you're dead.
Right. So shocked would be if you don't die, you get shocked.
Fine. Okay.
So there, electrocuted means electrocuted to death. So before we jump right into can my motorcycle really kill me with electricity, I think it's important to understand a little bit about how electricity works and how electricity on motorcycle works. So I kind of know the basics with voltage and amperes and current, and how they all kind of work together in a mathematical proportional formula. But when you're talking about electricity, which one of those is which and which does what?
Well, basically, volts is a measure of power.
Okay.
And, of course, most cars and motorcycles work with a 12-volt DC, direct current, electrical system. Cars and motorcycles are almost identical in the way that they use electricity. Basically, the storage of the power is your battery.
Okay.
And your battery technically really would read 12.6 volts.
Sure.
Just the way it works. But basically, the battery stores energy so that you can start the engine.
All right.
And of course, when you turn the key, many of the circuits get energized from the battery. So your instruments
come on, your headlight
come alive. Your headlight typically goes on, the running lights and tail lights. So
you can beep your horn and all that kind of stuff. You can beep
your horn and all that. So, but not everything comes alive at that point. But basically, when you turn the key, when you turn it to the first click to the ignition on, you are connecting the battery with 12 volts to many of the systems in the bike. And then when you turn it to start, when you push the start button,
or in your car, you would turn it all the way to start.
The rest of the way. Same difference. Basically, once certain conditions are met or certain interlocks are satisfied, then you can push the starter button,
and your engine will start
on your bike, and the second step takes place, and that is connecting the battery through a heavy cable to the starter motor.
Okay.
Of course, the starter motor requires a lot of current, amps, like 100 amps, whereas your lights require like 1 amp, very little. Hence, the wiring from the key switch to all the various parts of the bike is very lightweight. Because
and that's called a gauge, correctly?
That's correct, right.
So, and if I remember correctly, I just used the word correctly, incorrectly. If I remember correctly, a bigger number means a smaller diameter wire.
Yes, that's
so
correct.
A 10 gauge wire is very thick, and a 22 gauge wire is very thin.
Right, that's correct. And the cable that goes from the battery through the starter solenoid or relay to the starter motor is very heavy. It's like the size of your finger, because while it's still just the same 12 volts, the starter motor is going to draw like 100 amps, which is a tremendous amount of energy.
So what would happen if you try to put 100 amps through a wire that's too small?
It would melt.
It would melt. Okay, and then
it would just go away.
And then you would have no connection.
That's correct. You would have no connection.
Could that start a fire?
Yes, it could.
Okay, and that would be bad.
Right. To go off on a little tangent here, one of the problems that we run into, especially on bikes, not so much in cars, but more on bikes, is that the manufacturers, what we call highly engineer the electrical system. That means that they figure out exactly how much current is going to go through each wire, and they make the wire only that big.
Sure.
Which makes sense. Yeah. However, if there's the slightest little glitch in the system, some of those wires are so small that they will
fry out.
They could melt, short out. And of course, most of the circuits in the bike are protected by fuses. And in theory, the fuse should blow before the wire melts.
Right. So the whole idea, from my understanding, is that the job of a fuse is to protect the wire. Because fuses are much easier to replace than wiring harnesses.
Right. Yes, of course. Yeah, so the fuse protects the wire and protects components as well.
Right, because if you don't want to put 100 amps to your headlight, it would blow up.
Yeah, right. And so that's why there are, in your fuse box or fuse boxes on a bike, and often they have more than one fuse set up. That's why the fuses have different current ratings.
Sure.
15 amp fuse for certain parts of the circuit, and other things might have only like a 5 amp fuse. For example, like the wiring that would go to your GPS or some auxiliary device, that only requires 1 or 2 amps. So then they put a 3 amp or a 5 amp fuse in some places, and then in other places there'll be 15 amp fuses, and in other places there'll be up to 30 amp fuses. The fuses that are used now, whether they're the what I call the full-size ones or the mini ones,
the little tiny ones,
they only go up to 30 amps, and that's it. So on a lot of machines you'll find, like on the starter solenoid, there's sort of like a main fuse there, and that's a different type of a fuse. That might be a 50 amp fuse.
Right, because more power's going through there.
Because more power's going through there.
It's not exactly it's not part of the rest of that wiring system.
That's right.
It's kind of outside of the other fuses.
That's right.
Okay, so when you hit that button, the bike is going to go through. You might have a kickstand interlock. You might have a clutch switch, a clutch interlock to make sure your clutch lever is pulled. Those kinds of things that will prevent you from starting your motorcycle in a fashion that could result in your injury by the motorcycle suddenly jerking forward. So we get past all that. The starter motor engages. The flywheel turns the crank. Your bike starts. Vroom, vroom, vroom.
Well, and at the same time, we turn on the ignition system.
Turn on the ignition system. Okay. Right. So that's your.
Yeah.
You might coils or however it works on your particular bike sends electricity through a cable to a spark plug.
Right.
Ignites the gas and all that kind of stuff in your bike.
All of that has to work in unison.
Sounds kind of magical.
Yeah, well, it sounds magical. 30 years ago, the bikes were a hell of a lot simpler. And you could really, with a meter, you could troubleshoot whatever problem you had in a short time.
And now you can still, and we'll talk about meters in a minute.
Right.
You can troubleshoot some things with a meter, but now bikes are so computerized now that you have to have some kind of diagnostic tool.
Right. In fact, some bikes don't even have fuses, like BMWs, where my
BMWs have fuses.
The newer ones don't.
I did not know that.
And basically, the computer, the thinking box in there is keeping an eye on the current draw of all the different circuits, and it says, "Whoa, that circuit's out of line. Something's wrong there, so I'll just shut that down." So this is all done internally, and then it will typically reset itself, but it makes it a little more dreamy to figure out what's wrong.
Yeah, I bet.
Yeah. Right.
So my bike is started. It's running. I'm sitting there in neutral in my driveway. Now, you just told me that all of my lights and the other stuff is being powered by the battery. So if that continues for too long, it's going to drain my battery.
That's right.
So how does the system prevent the battery from going flat?
Well, basically, every bike has, in the old days, a generator, but now an alternator, which is typically on the crankshaft, on one end of the crankshaft, and that creates electricity. It actually generates AC electricity.
So the battery produces direct current, DC.
And the whole bike runs on DC. Everything on the bike is DC. Okay. Every device. Except the alternator,
which is AC, alternating current.
Which creates alternating current, and that then goes into the rectifier or rectifier regulator, which often is in one unit. And that converts the AC power to...
we got a quick phone call to deal with here.
Can you stop that?
Yeah. All right, we had to take a break to answer a phone call, and it might surprise the bank of listeners that it was an electrical problem, but that doesn't really surprise me because I know people call you with electrical problems all the time. So we got to alternator creates AC, and then your regulator rectifier system converts it to DC. And then
that recharges the battery and supplies power to all of the components in the system. Basically, it's not really running off it's running off the battery as it needs to, but generally your alternator is supplying power for the whole bike to run.
Okay, so here's a question that might seem obvious to some people, but it doesn't seem obvious to me, so I'm going to ask the question. What's the difference between an alternator and a stator? Because I know some bikes have stators.
The stator is part of the alternator.
The stator is part of the alternator.
Right. One part of it rotates, and another part of it, and I forget the name, the stator and the thingy. Yeah. There are two parts. One turns, the other part doesn't.
Okay.
It's stationary. It's like the field.
Okay.
But anyway, it creates AC, and it creates like 40 or 50 or 60 volts, which is way more than the 12 volts.
Right.
But then it converts it to DC, and it regulates that DC to somewhere between 13.8 and 15 volts.
Which is a lot closer to 12 than 40 or 50.
Right. And you need more than in order to charge the battery, you need more than 12 volts.
Right.
In order to...
You have to like get over the battery's threshold.
Right. That's exactly right. And on two of my bikes, I've actually installed a digital voltmeter so that I can watch while I'm riding and while I'm using various accessories, particularly heated gear, which draws significant current, and heated grips, you know, and heated seat, and all those things are drawing from the alternator. And so by having a digital voltmeter there, I can see that I'm not exceeding what the alternator's putting out. If while I'm riding along and I have extra lights on and heated grips and my heated gear, and I see that I'm at 12.1 volts, then I know I got a problem. And in fact, if I stop for a light and the bike is only idling and the alternator is not putting out much power, then my meter may go down below 12.5 volts. I've even seen it down in the 11s. But as long as that's only for a minute or two, the battery can take care of that surge.
Once you get going again.
Well, it's taking care of it now while I'm sitting there. And then once I get going again and the alternator starts putting out 40 or 50 volts, and now we're recharging the battery again. You know,
Gotcha.
now the volts are up, you know,
Where they need to be.
13.8, 13.9, 14.1 in that range. Now you're okay.
So that it brings to mind a piece that I wrote some time ago about the different types of batteries. And the kind of batteries that a lot of people use in motorcycles nowadays are the gel type batteries that they don't have liquid sloshing around in them. It's much more safer. That's pretty good English. It's much safer for motorcycles because they can fall over, they can tip over, they crash, they could end up upside down. But the big thing now is the lithium iron batteries.
Lithium ion.
Smaller and lighter. But they have a higher resting voltage of something, you know, over 13 or 14. I don't remember exactly what it was. I'd have to go back and look.
Right.
So an older bike that, you know, maybe its regulator or rectifier or alternator is really only putting out enough to get that, like, say 13.8, and that's the max.
Right.
If the battery's resting voltage, natural voltage, is 14.1, 13.8 is never going to charge that battery.
Correct.
So those lithium batteries, you got to make sure that your charging system gets over its threshold.
Right. Yes.
Okay, good. I thought that was where I was going, where my mind went.
Yeah.
So
I'm not entirely familiar with that. I just know that in my Triumph, my battery is laying on its side. Obviously, it doesn't have liquid in it.
Yeah, that's a gel battery at least.
It's a gel battery at least. Because there it is, just laying in there, and I'm thinking,
sideways.
If there were liquid in there, it would be
everywhere.
Everywhere.
Well, and of course, you know, you're old enough to remember when battery technology was wet acid batteries all the time, and you had to add, distilled water.
Add water. Yeah.
All on a regular basis because it just boils off through the natural process. But what I'll do is I'll put a link to that article in the show notes for this episode so people can go read it. So I still want to talk about meters, but I want to kind of get to the idea about my audiologist telling me this story about her neighbor getting electrocuted by his motorcycle, because to me, it doesn't, so far, none of the things that I've heard yet, even though the alternator might bump up to 40 or 50 volts, it doesn't sound lethal. My kind of negative experience with electricity comes from working on guitar amplifiers, which can carry a whole lot of voltage. And I've had some nasty shocks delivered by touching the wrong capacitor at the wrong time before a discharge, or somebody messing around with me, or just a circuit being bad and crossing over to where it's not supposed to cross over, and I touch something and zap and get fuzzed out a little bit. Obviously, I've never been electrocuted because I'm sitting here talking to you. So when I think of 12 volts in a motorcycle, or even 40 volts from an alternator, I don't feel like that should be dangerous. So what am I missing that killed my audiologist neighbor?
There are two things. First of all, the alternator, I guess in theory, could put out 50 or 60 volts or even more. Okay. And that could be enough to stop your heart.
Right, which is generally, from my research, if you get killed by electricity, you've either suffered a traumatic brain injury because it heats up the fluid boils the fluid in your brain, the heat from the electricity, or the electricity comes in one part of your body, leaves through another part of your body, and your heart gets in the middle, and that the electricity messes up your heart rhythm, which then kills you.
Yeah, I think it's more likely that this person grabbed onto some ignition component which starts at 12 volts but ends up being a couple thousand volts, very low amperage, but the voltage is enough to give you a bad shock. And particularly if your ticker's not in good shape.
Sure, certainly if you have a pacemaker or heart disease or some other valve problem with your heart that you don't, undiagnosed heart defect. Certainly if your health is already compromised, whether you know it or not, you're more susceptible to electrocution in the first place.
Yeah, but my sense is that this person allegedly,
because obviously you're not a doctor, you're not a paramedic, you weren't there.
My guess is that he was touching something with the high voltage ignition. Okay, and that could give you a pretty good zap.
Okay, so from a user standpoint, how can I, other than don't touch ignition components, which makes sense. Right. How can I prevent being electrocuted by a motorcycle? Or is it something that I really have to worry about if I'm careful?
Well, anytime you're fooling around with a bike that's running, the ignition system is putting out some serious, high voltage to spark that spark plug. And as long as all the components are together, and that cable and that sleeve are down over top of the spark plug, you're not really going to be access to that voltage. But if you're changing the plugs and you pull those cables out and they're laying over here, and you start the engine and the ignition is on, it could knock you on the floor.
So is that one of the reasons why, when I'm looking at my shop manual and I'm going to do some electrical work, it says disconnect the negative lead from the battery? Because if you don't have both battery cables connected, you don't have a circuit.
You have nothing.
You have nothing, right? So if you have nothing, then you can't energize the ignition components. You can't get electrocuted.
Correct. Yes.
So there's your important safety tip. If you're going to work on the electronics on your motorcycle, start by disconnecting your negative battery cable. Yeah. Why the negative and not the positive?
Technically, it doesn't matter.
Okay.
But the problem is, to diagnose most problems, you need the thing alive.
You have to have a circuit.
So they're telling you in the manual, make sure you disconnect the battery before you do anything. And of course, once you do that, most troubleshooting is not going to happen.
It's moot, right? So certainly, if you're going to work on the electronics on your motorcycle, you need to be very careful. So, and I don't know the answer to this. I'm going to ask a question I don't know the answer to. Let's transition to meters. Okay. I have never blown up a multimeter, but it sounds like there's enough electricity in a motorcycle to destroy a multimeter. If it can kill you, it can break another electronic device. So,
the problem with the multimeter, one of the problems with the multimeter, is that it can do a lot of different things.
Right.
And usually there's a knob on there.
A selector.
And if you select the wrong tool to do what you're doing, and then you put the two leads across 12 volts, you can damage the meter.
Okay.
Now, some meters actually have a fuse in them to prevent smoke in the meter, but not all of them do.
And don't some meters automatically adjust? Like they don't have knobs on them; they have internal circuitry that says, "Oh, I must be doing, DC or something."
Yes, some meters do. Most meters don't. Most meters have a selector that so that you can set either AC volts at different levels, DC volts at different levels, current, which is amps or milliamps, thousandths of an amp.
Right.
And if you set it to measure anything with amps, and then because to measure amps, you want to be within the circuit. But actually, if you then take the two leads, the red and the black, and connect them to 12 volts, the meter is not going to like it.
Okay.
Yeah, so it may blow a fuse in the meter. It may
let the magic blue smoke out.
Done. Yeah, right, exactly. And then there's also you're measuring ohms, which is resistance. That's another thing. And if you set your meter on ohms and connect the two leads to 12 volts, it won't be happy.
Not like that either.
That's right, done like that.
Okay.
So you need to have some very basic understanding of what you're trying to do and how to tell the meter, here's what I want to do. And so you set that selector in the right place before you start touching things with the leads.
Right. And now I don't do a lot of speculative work on the electrical system on my motorcycles. I might attach lights, or a louder horn. But a lot of times I'm connecting them directly to the battery with their own inline fuse. They come from the manufacturer with a kit, little wiring kit, and you connect this one to positive and connect this one to negative, and, you're hot. A lot of people that I know that have multiple accessories will often add a little, like an auxiliary fuse box. So the extra fuse box, they hide it somewhere under the seat or under a body panel somewhere. They connect that to the battery, and then they connect their heated vest and their aux lights and their loud horn to the fuse box.
To the new fuse box.
To the new fuse box, right. So
in fact, when you're doing that, there's another little variation on that, and that is what I have done on many bikes is to put a relay in between the battery and my auxiliary fuse block.
Okay.
And that relay is basically just a switch that closes when I want it to, so that I provide power to all of these accessories.
Okay.
And of course, then none of them can work until I close that relay.
Exactly.
And normally,
and the relay just has like a little electromagnet in it that closes either.
Right.
It's either off when it's not energized and on when it is, or it's off when it's energized and on when it's not.
In this case, we're always using it normally open.
Right.
That means when we're not energizing it, there's no circuit, there's no power flowing, and those auxiliary fuses are not being energized. So those circuits are not being energized.
Okay.
So basically, you need to figure out what's the best way to energize that relay and power up these accessories. And what I found to be universally workable is to use a wire that's going to the tail bulb.
Yeah, a lot of people do.
Those are always under the seat. Obviously, they got to get out the back. So it's usually pretty easy to find which one goes to the tail light. And then when you turn your key on and the tail bulb goes on, that closes a relay, and that gives you power for your
extra fuse box.
For your extra circuits,
Okay.
the GPS, the connector for the heated
vest and all that stuff.
Your extra lights in the front, in the back, whatever.
Your swamp cooler, your
all of that. Yeah.
Cigar humidor, all the things that we put on our motorcycles.
Right.
So if but before I ask this next question, I want to remind everybody that's listening that when in doubt, go to a pro, go to a tech that knows what they're doing, and let them do the work for you. Don't guess at electronics, because it's a really easy way to need to replace the entire wiring harness on your motorcycle, which you don't want to do, trust me. So on these newer bikes that you were telling us about that are all computerized and don't have fuses, traditional fuses like we think of, how do you connect extra accessories to those bikes? Because you can't reprogram the computer. There's no way that Harley-Davidson or BMW is going to let Wes or Stuart reprogram that bike's computer in their garage. So is that doing it the way you were talking about with the battery connection and the relay? Is that the only way to connect accessories to a really cutting edge motorcycle?
It's one way to do it, and another way is to use, for example, on the newer BMWs that have that are controlled by the ECU.
Right. Is that the CAN bus system?
Right. That's the CAN bus system. With a CAN bus system, you've got two options. You can either buy accessories that are meant to be used with CAN bus.
Okay.
And of course, then you can let the dealer take care of that.
Sure.
Which they'll do. Or you can put a separate fuse block in. And there's actually some of the fuse blocks are split so that you can have some of those circuits powered all the time, still through a fuse. Mm-hmm. And I mean a fuse in between the battery and the fuse block. Mm-hmm. So it's still protected. But some of those circuits can be on all the time. For example, you might want your GPS to be powered all the time. If you've got a charging plug for your iPhone or things like that, you may want them to be on all the time. So you have the option of doing that. And then other of the circuits, like heated gear, like heated seat, so on, extra lights, you really don't want them on. You don't want them drawing power until the bike is running and stable. So, those type of split fuse blocks allow you to select which circuits are on all the time, usually just one or two of them, and then the other ones are on just when this relay is kicked in by your tail light. So you're pretty much working, you're sort of going around the bike's system by doing that, and you're going around the electronics.
So is that an intelligent thing to do with your $15,000 or $25,000 motorcycle to circumvent the built-in electrical system?
Yes, if you know what you're doing, it's a good thing to do.
Right.
It's fine. If you don't, if you're not absolutely sure about this circuitry and this kind of wiring, then you let the dealer do it and cough up the bucks.
Yeah,
that's it.
So what's a good way for people to learn the basics of electrical systems? I mean, do you know of like a website or a book or anything like that? I mean, I can go home and do the research and put the links in the show notes later. I'm just asking if you know anything off the top of your head.
Well, basically,
like, how did you learn all this stuff? I have this mental picture of you blowing things up and learning the hard way. Coming home, clearly you have all your fingers, so you're doing all right.
Actually, I owned a number of British motorcycles.
So you had no choice but to learn electronics.
Back in the 70s, so I had no choice. Yeah,
right. And those 60s and 70s British motorcycles are notorious for their poor electrical systems.
That's right. And in fact, some of those bikes, the whole system ran on one fuse or maybe two fuses. And the wiring loom, as it's called, was very simple, back then. I mean, you had your battery, you had your starting circuit, your charging circuit. All of that was just a handful of wires. And then there'd be a couple of more wires that would go up to your headlight, and geez, some of those bikes even had turn signals, and
the horror.
Yeah, horn and so on. So they were really simple, but they broke a lot. So you really had to figure. You had to be able to figure out. You had to become competent. That was it.
Very quickly. Yeah, the probably the most complex thing I've ever done with one of my own motorcycles was I used to ride CB 750s back in for me it was in the late 80s and 90s, but those bikes came from the mid to late 70s, the ones that I liked. And they had pretty simple electrical systems. There was nothing complex. There were no computers involved. Carbureted motorcycles don't need computers. But I remember having to replace one of the wiring harnesses, a wiring loom, basically that bulk of wires that connects one end of the bike to the other and has the stuff hanging off of it. And, it was, I don't want to say it was easy because it wasn't easy, but it was simple in that once I was able to expose the wires, the ends of the wires, I could take the new harness, unplug the old connectors, plug in the new connectors, and then basically pull one up as I laid the other one down, zip tie it into place.
Exactly.
But you can't really do that with a modern motorcycle, and certainly not as in that simple a fashion, just because there's so much wiring on a motorcycle.
Well, what I was going to say before is when you have a shop manual, there are numerous wiring diagrams. But here we're looking at a manual here for Triumph, which has, all the modern stuff, certainly. But what they've done is broken it down so that there are multiple simple diagrams. The first diagram is the lighting circuit. So that has your ignition switch and starter relay and tail lights and things like that, different warning lights. You got your key to the wiring colors. All right, so that's mostly for the lighting. Then your next one is the starting and charging circuit.
So they kind of break it down by system.
Break it down by system. So here you have the battery, starter solenoid, starter motor, and your regulator and your rectifier and all that stuff. Here's a cooling fan relay, engine kill switch, fuel pump relay, things like that. So that's all in the starting and charging diagram.
And those diagrams probably make sense to you. They make a little sense to me due to my background with amplifiers.
Yeah.
Because, switches are switches at a certain point, and, resistors and capacitors are components in an electrical system.
Yes, they make sense, but looking at the diagram on a flat piece of paper
is not the same.
Is not the same as finding different components on your bike under 37 different plastic panels and all this stuff. And
is that the same guy?
No, that's my son.
So we'll blow off your son for the show.
For now. Basically, when you look at this diagram, it shows that certain connections are made in certain places.
Sure.
That's not necessarily how the wiring is on the bike.
Gotcha.
Certain connections may be made in other places. Electrically, it's the same.
Right. Because a circuit's a circuit.
Yeah, but so anyway, so we have the starting and charging circuit. Then there is the next diagram is auxiliary and accessory circuits. So this has the brake lights, the horns, things like diagnostic stuff, turn signals, of course. So here's yet another fairly simple diagram, but again, not all the connections are made in the same points on the bike. That's where it gets a little interesting. And then finally, you have the main wiring circuit diagram. And in the case of this bike, you've got models without ABS brakes because they're a lot more complicated.
And they'll have their own circuitry.
Right, and then you have main wiring circuit diagram models with ABS brakes. So now you have this
whole big page.
Yeah, a big open out 11 by 17 page, with every component that's on the bike
laid out in two dimensions.
It's laid out in two dimensions. It's not necessarily where it is on the bike.
Yeah, and certainly, even a big piece of paper is not the same size as the motorcycle.
You could make this on a huge piece of paper. You could plot it on a D-size plotter, but the components are lined up for ease of displaying the wiring on the paper, which ain't the way it is on the bike.
No.
So if you study the individual simpler diagrams first and understand where those parts are on the bike, and then eventually start referring back to the main circuit diagram,
you can put it together.
You can eventually put it together. So in terms of being able to diagnose problems, because on a modern bike, there are so many what we call black boxes, where you have, it may not be black, it might be silver, it might be whatever.
But wires go in one side and
lots of wires going in one side and coming out the other side, and you don't really understand what inputs make which outputs work.
Right.
So when your turn signals don't work and it ain't a fuse, it's a little hard to figure out what's going on.
Yeah. So you might need to hook your bike up to a diagnostic tool to read an error code, or take it to a dealer to have them put it on their computer or something like that.
That is correct. That is correct.
All right. So what would you, to give everybody a nice warm fuzzy here at the end to wrap up, for let's say a relatively competent home mechanic, electrical systems in general, adding accessories, let's say specifically, achievable, not achievable for, an average, home, I can change my oil and, set up my shocks kind of, person. You guys are listening, of course. You can't see the face that he just made. I'm not sure he wants to answer that question.
Well, no, I do want to answer the question. I would say that an average guy who's sort of competent, and you can go and flip your circuit breaker and get your furnace back on, this is a little beyond that. Mm-hmm. And the risks are pretty high to screwing something up on your bike.
Right.
So as far as, when you buy certain accessories like lights, now of course, fortunately these days lights are mostly going to be LED.
Right.
So they take very little current, so the wiring is small. So you could probably, install some auxiliary driving lights, and because the LED lights require so little power, amps that is, you may be able to just sort of piggyback some existing wire, like the running light on the front, under the headlight. You can go into that circuit,
right?
And then, of course, most of these auxiliary lights will come with a little wiring kit that will have a fuse, perhaps, and a relay and a little switch that you mount on the handlebar. So if you're very careful about what you do, you could do that. Adding a louder horn, different story.
Right.
Because a horn draws a lot of current.
Yeah.
And if you just replace the existing horn, which is useless,
with the loud horn.
With a louder horn, it may draw too much current.
And that'll fry the wires.
And that can be a problem. Yeah.
Because I know when I put the new horn on my motorcycle, I had to put a relay on it, and it has its own fuse and goes straight to the battery.
Right. Yeah. So that's where things get a little more complicated. And again, if you have an auxiliary outlet on the bike, a lot of current bikes will have one. Mm-hmm. But in some cases, it's fused with a 3-amp fuse.
Right.
Well, then you go and try to plug in your little air compressor on the side of the road, and that fuse goes away in a tenth of a second.
Yeah.
Well, so then if you put a bigger fuse in to be able to handle the little air compressor, the wiring is not adequate for that.
Right. So then
somebody can very easily
bypass the fuse, but you'll still overload the wires.
Which is much more dangerous than blowing the fuse.
Right.
Because if you put a 15-amp fuse in, which will handle the current of your little air compressor or your heated jacket or whatever, and now that is feeding power potentially up to 15 amps through a wire that's like 4 hairs wide, you got a problem.
So that sounds like an important safety tip, to always use the specified fuse in a given circuit on your motorcycle, especially on your motorcycle, but in general, because if your car blows a fuse, you can pull over to the side of the road. If your bike blows a fuse and you're going 70 miles an hour, you could have a real problem.
Or worse. Yes, right. That's correct.
Or a fire. You never want to be riding down the road and look down at your motorcycle tank and the crotch of your motorcycle pants and see fire.
Correct. Yeah, right.
Maybe that was a little dramatic.
So, while I don't want to dissuade people from attempting to, take care of their bike,
you have to be. It sounds like what I hear you telling me is that you need to be smart about it, and you need to get a little bit of education, get a little bit of information, and make sure that you know what you're doing before you go ahead and do it, instead of just kind of guessing at what you're doing.
Right, and certainly with installing some accessories, they will come with instructions that may or may not be adequate, but I've found recently, especially in the past couple of years, that there is a wealth of information when you go into forums for specific bikes, for specific models.
Yeah, definitely.
There's a lot of good information there on how to go about troubleshooting, how to wire certain things in, and so on.
Yeah, when I got my KTM last year, the first thing I did was find the KTM forum and join it and introduce myself and start looking around.
Right, exactly. Yes.
All right. Well, Stuart, thank you very much for talking about electronics with us. If I have any other questions, I know where to find you, and maybe we'll get you on again next time to talk about some other electrical stuff.
Thanks for having me.
There you go. I'm working on a multi-part series of articles on motorcycle electrical systems for my regular tech column called The Torque of the Matter. The only way to get these articles is to join the MOA for a year so you can get the BMW Owners News magazine the articles will be in. A 1-year membership costs $49, and you've heard me mention a number of benefits to membership in previous episodes. Being a member also makes you eligible for the MOA's roadside assistance and tire insurance programs, both of which can easily pay for themselves several times over if you have problems with your bikes. Head over to bmwmoa.org to learn more about the benefits of membership and how to sign up for a 1 or 2 year membership. Don't forget to check in with me by getting connected to one of the show's social media feeds, Facebook, Twitter, or Instagram, and especially by checking out the website at horizon.bmwmoa.org. You can also email me at podcast@bmwmoa.org. And if you're really saucy, you can join the mailing list by heading over to tinyletter.com/chasingthehorizon. There's a lot on deck for Season 2 of the show, including our first official sponsor, new music, new logos, a new URL, and most especially new guests. I'll be kicking off Season 2 with Motorcycle Manufacturer Month. Starting on Monday, September 3rd, 2018, there will be two-part episodes featuring discussions with 2 different motorcycle builders. The first 2-parter features Matt Chambers, the head of Curtis Motorcycles, and the second 2-parter features Brian Case, co-founder and lead designer for Modus Motorcycles. I promise I won't use the word "to" one more time in this episode. Thank you for coming back for the 28th episode of Chasing the Horizon, which featured a discussion with Stuart Ostroff, an electrical expert. Stay tuned for the first episode of Season 2 in a couple of weeks. Thanks again to all our guests and listeners for giving us their time. I especially want to thank 2 people. One is a group of people, all of you guys, for listening to and supporting the podcast throughout the first season. And the second is my friend Andrew Finberg, who wrote, recorded, composed, however you want to say it, played the music that you hear at the top and bottom of the show, and the little interstitial funky little thing that indicates a change in segment. Even though I'm going to be changing the music for the second season, I just wanted to give Andrew one more shout out and tell him how much I appreciate his effort for letting me use that music. We'll see you out there somewhere on the road, or off it. Ride safe.